In this video, we will be sketching parametric curves. So remember, when you look at a parametric equation, this thing here tells you the x location of the particle. This tells you the y location of the particle for a given time. So for example, looking at this will tell you the x location, this will tell you the y location. So when you first glance at this, you should be able to tell that it's going to be a straight line because x and y they increase on par with each other. So for example, when t equals 0, put into here, put 0 into here. So this will be comma 0, comma 0, which will be right here. When t is 1, put it into here. The location will be 1, comma 1, which will be, let's say here, 1 across, 1 up, which will be right here. When t equals 2, put it into here, the location will be 2, comma 2, which will be right here. When it's 3, put it into here, the location will be 3, comma 3, which will be somewhere around here. So you can tell that because this increases by the same amount as the y direction, then you're going to get a straight line. But then you also have to look at the domain for this. This is from negative infinity, the time is being negative infinity to infinity. So when t equals negative 1, put it into here, the location will be negative 1, comma negative 1. So negative 1 is here, and negative 1 is here. So it's going to be here. So when time is negative 2, the location will be negative 2, comma negative 2, which will be here. So you're going to get a straight line. But then when you look at the domain, it starts at negative infinity. So it's going to be here, and then it travels all the way to here. So you got to think of it like this. Hang on. So when t is 0, the particle will be right here, 0, 0. When t is 3, let's just say this is 3 here. When t is negative 3, it's here. Let's just say this is negative 3. So when you look at this, it starts at negative infinity, and then it moves all the way in this direction. So you can actually you can actually communicate the direction of the particle. So it starts at negative infinity, and then it moves towards the right. So you can actually put some arrows on there. So next example. Hang on. So next example. So when you see this, you've got to again, it's going to be a straight line because x is going to increase by the same amount as the y direction. So in your mind, you've got to picture the timeline when it comes to parametric equations. So picture the timeline. The domain is from 0 to 2 pi. So we can forget about negative time. And then in your mind, you also got to picture this sine graph. So the sine graph looks like this. So let's start at 0. When t equals 0, put it into here. When t equals 0, sine of 0 will be 0, and y will be 0 here. So the location will be 0, 0, which will be right here. When time is pi over 2, put this into here. Sine of pi over 2 will be 1. So the location when time is pi over 2, the location will be 1 because sine of pi over 2 is 1, comma 1. So it's going to be right here. So when time is pi, the location. So when you put pi into here, sine of pi will be 0, and then here sine of pi will be 0. So the location will be 0. So the particle is going to travel in a straight line here, and then it's going to travel back to the 0. So this is back to the 0. When time is 3 pi over 2, you put 3 pi over 2 into the sine t, then that would be negative 1. So the x location would be negative 1. 3 pi over 2, put it into here. The y location will be negative 1. So it will be right here. So at time 3 pi over 2, it's going to be here, and then at 2 pi, put into here, the location will be back to 0, 0. So it's going to go back to here. So what's actually happening is this: the particle starts here, it moves up to here, and then it travels back, and then it travels here, and then it travels back again. So you can actually tell the movement of the particle when you're using parametric equations. So next one, Next example, hang on. So to sketch this, again, you should be able to tell that it's going to be a straight line. So in your mind, when it comes to parametric equations, picture the timeline. So this will be your parameter, and then because e to the power of t, picture this in your mind as well. So let's look what happens when t is really big. Let's say negatively big. Let's say minus 99999. So you can see when t is negative 99999, it's going to be well, when you put this into here, this thing here is going to be a very small number, 0.00000, let's say 1, and then put it into here. It's going to be a very small number. You can see that right here, comma 0.0000. So not 1. So it's going to be very close to the origin, but it can't be at the origin because this thing here would never reach 0. So you're going to have this white circle here, and then when time is 0, put it into here, and then into here, and then when time equals 0, this thing here will be 1, and then comma, this thing here will be 1. So it's going to be 1. It's going to be right here. And then when time is very big, you can see it's going to get, well, let's imagine time to be a really big number. You put into here, so this thing here would be a very big number. So when time is very big, you put into here, this is going to be very big, comma, very big. So in the x direction, it would be very big. In the y direction, it's going to be very big. Let's just imagine it to be somewhere around here. So remember that when it's very big, negatively big, let's say minus 9999, it's going to be somewhere around here. By the time it gets to 1, by the time time gets to 0, it's going to be 1. So this is 1. And when time gets very big, it's just going to be very big. So your line here, the path of your particle will look like this. It will just get bigger and bigger. So the arrow will be like this. There will be nothing in the negative realm because there's nothing in the negative realm over here. So your line will look like this with a circle in the middle, and then it travels all the way up here. Okay. Next example. So when you sketch this, again, you should be able to tell that this is going to be a straight line because x and y moves on par with each other. And then picture the timeline in your mind, and then because of this, x to the power of 3, picture x to the power of 3 in your mind. So for simplicity, let's start at 0. So when time is 0, you put into here. When time equals 0, the particle will be at 0, 0. So when time equals 0, it will be right here. When time, remember our domain is from -1 to 1. So when it's at 1, when it's at 1, put into here, the particle will be at the location 1, 1, which will be here. When time is -1, the location will be, well, put -1 into here and into here. The location, this thing here will be -1. This thing here will be -1. So the particle will be right here. So if you're a particle and you start here and then you move all the way here, it will look like this. It would just be a straight line from -1 to 1. When time equals 0, the particle will be right here. So your line will look like this. So you can put some arrows in there. Okay.